Hi everyone, welcome back to System Verilog Assertion series. So in the previous two sessions we have already discussed about the introduction to assertions and what are the types of assertions like immediate and concurrent assertions. And we have also seen how to develop an immediate assertion, right? And also we have seen how to create a sequence and property within the concurrent assertions. Now in today's video let us see how we are going to write an assertion, right? Like what are the ways in which we can create the assertions based on the condition or logic that we want to check on that particular design. So there are various ways in order to implement or write your assertions. So in today's video we are going to discuss about those various ways. And before going into today's session, if you are new to this channel, consider subscribing the channel and hit on the notification bell also follow me on LinkedIn and also on my Telegram channel to know the updates related to Verilog internships as well as Verilog opportunities. VLS opportunities. Right now, coming to how to develop a system Verilog assertion sequence. Right. So in concurrent assertions, we have already discussed that we can have any number of sequences. Like we can have three or four number of sequences also. And what we will be doing instead of asserting all these individually, we will be combining all these assertions into a property, and then we will just assert that property so that all the sequences within this property will also be asserted, right? So in today's video we are going to see how we are going to assert these properties or how we are going to create this sequences, right? So if you see the first thing here, sequence, okay, sequence which should be followed by sequence name, which is sequence now here what is the condition that I am writing? At the rate of passage of clock a equal to 1, double equal to 1. So that means for every positive edge of the clock, what is the meaning of this assertion? So if you want that particular input like a want to be if you want that to be high for every passage of clock, then you should be giving it in this format, so that it will be checking that whether a is continuously 1 for all the positive edges of clock. And if at any point of time if a value has become to 0, that means if a is low, then at that point of time the assertion will be showing you as a failure. At that time sequence it is showing that the assertion is failed. So what can you do? You can just check that assertion, and based on the time slot that it is given, you can go there and check it out why that a value has become too low at that particular point of time, right? So in this way you can check the debugs easily by using the assertions. So this is how you will be writing if you want particular input to be high for every passage of clock, right? Now if you have two inputs, okay, and if you want to check if you have a condition like that either of these inputs should not be both the inputs should not be low, at least one input should be high, so that that particular logic will be happening. So how we are going to write that? See, at the rate of passage of clock a or b, this means either a or b should be high for every passage of clock, okay. If both of these are low, then the assertion happens to be failed. Got it? So if you want both the inputs to be high, then what you'll do? Instead of or, you'll be keeping AND operator, so that what happens? For every passage of clock both a and b should be high. If both a and b are not high, then what happens? The assertion will be failed. Okay, in this way the assertion will be happening, right? If either of a or b is high, if both signals are low, then the assertion will fail. Got it? Now for the same thing, for example, this is how you will be using the logical operators here, a sequence with the logical relationship, like or operator, and operator, negation. So all this you can do it, right? Now sequence with timing relationships, this is really important. So basically you are having a logic that, for example, you are having two inputs a and b, and after a is high, then after one clock cycle the b should be high. Okay, so this is your logic. So how are you going to mention it? Okay, you got my point. A should be high, and after a is high, then after next clock cycle the b should be high. So this is how you should be designing. This is how you should check your design. Then how we are going to write it as an assertion? A hash hash 1 of B. That means what happens? Hash hash means it's a delay symbol. Okay, you already know that hash is nothing but it's a delay symbol. So in assertions you will be using double hash in order to show the clock delay. Okay, so what happens? For after A is high, hash hash 1, that means after one clock cycle B will be high. Now if you see here hash hash 2, that means after A is high, then after two clock cycles B will be high. Got my point? See, the sequence checks for signal A being high on a given positive edge. For every positive edge of clock, it will check whether A is high or not. If A is not high, then it doesn't check the B condition. But if A is high, then what happens? If A is not high, then the sequence fails obviously, because since A is not high, the assertion is failed. So what is the condition here? If A is high, then after two clock cycles, B should be high. So this is my condition. And now if A is high on any positive of cycle, the signal B should be high for two clock cycles after that. That means for first clock cycle if A is high, then after two clock cycles the B should be high. So this is the condition. If this condition is, that means after two clock cycles if B is not high, then the assertion fails. Got my point? Yes, so this is clear. So this is how you will be checking the assertions. So clock delays are in this way, like hash hash represents the clock delay or cycle delay. So for how many clock cycles you want to take delay, it will be giving it as a number, like hash hash 1, that means one clock cycle. 2 clock cycles, right? So if it's hash hash 0 means both should happen. For example, if you want that to happen both at the same time, then you will be giving it as A hash hash 0 B. That means as soon as A is high, the B should be high in that same clock cycle itself. Clear? So again you can give it as a range also, like you can give, for example, if you are giving it as 4 to 6, then what happens? Between 4, after A is high, between 4 to 6 clock cycles the B should be high. Clear? So this is how you will be mentioning it, the clock delays. Clear? Yes. So if you see the example here, hash hash 0 means there should be no delay. Expression on LHS and RHS should hold true at the same time. Okay, that means both should be true at the same time. If it is hash hash 1, that means after particular expression in RHS is completed, then the LHS thing should be taking place. Clear? Now 2 to 4, that means within the range. That means after first thing is checked, then within 2 to 4 clock cycles the second thing should be high, or second input should be high. Clear? Yes. So in this way again, if you want the same thing to happen for some 4 or 5 clock cycles, then how can you do? There are repetition operators within assertions. So let us see how we are going to use this repetition operators. So if you see here, sequence within the sequence and unsequence, for every passage of clock, okay, request 1 hash hash 1 request 2. So just check these, only this thing. What happens now? So as soon as the request 1 is high, after one clock cycle delay, the request 2 should be high. Clear? So this is the condition. But the same thing should happen for 3 number of times. That means after request 1 is high, then for continuous 3 clock cycles, the request 2 should be high. Clear? If any of this condition fails, the assertion will be failing. That means after, for example, if you are taking it as this is my clock, okay, this is my clock and this is my request, okay, 1, and this is my request 2. Now what happens here? The request 1 is high at first clock cycle. Now what happens? After request 1 is high for the first clock cycle, the request 2 should be high for the next clock cycle. Okay, this is second, third, 4, 5, 6 clock cycles for every passage of clock, right? So for the next passage of clock, the request 2 should be high, and again for the second time also it should be high, for the second clock cycle also, for the third clock cycle also it should be high. If within these 3 clock cycles, if any, for example, if for these 2 clock cycles if it is high, and for the next clock cycle if it is low, then the assertion fails. Okay, that means it should be continuously high for the next 3 consecutive clock cycles. So that is what meant by this particular logic. Okay, request 1 hash hash 1 request 2, within the square brackets you are giving it for 3 times. That means continuously it should be high for 3 consecutive clock cycles. Clear? Now either you can write it in this way easily, or you can just give it as like this. If you see, instead of this you can write it as request 1 hash hash 1 request 2 hash hash 1 request 2 hash hash. That means total of 1 2 3. So instead of giving this, you can just give it in this manner also. Clear? Now the same thing, like if you see here, 3 consecutive clock cycles. Now you can give it in range also. Now if you see here, request 1 will be high, then request 2 should be high within 2 to 4 clock cycles. That means you are giving the range. Okay, so it must be true. It must be true for minimum 2 and maximum of 4 clock cycles. That means either 2 clock cycles it should be high, or continuously 4. Within 2 3 4 clock cycles, at least it should be high for 2 clock cycles, and maximum it can be high for 4 clock cycles. Clear? So this is the range I am giving. That means within 2 to 4, between 2 to 4 clock cycles it can be high for any number of cycles. But it should not be, if it is only 1 clock cycle high, then the assertion is failed. If it is for 5 clock cycles or 5 high also, the assertion will be failed. Only it should be between 2 3 and 4. So this is the range. Okay, for example, here as I told you, you want it to be high for continuous 3 consecutive cycles. Now if there is a condition that it should be high, but there is no mandatory that it should be continuous, then how can you write? Instead of the star symbol, you can just mention equal to symbol. That means here if you see, the request 1 is high and the request 2 will be high for the next 4 clock cycles, but it may not be continuous. That means after 3 clock cycles it can be high, and then after 2, and then after 1 it can be high. But after request 1 is high, for at least 4 times the request 2 should be high. Okay, but it is not mandatory that they should be consecutive. Clear? So this is the condition for in this manner. In these many ways you can write the assertions based on the logic and based on the condition that you are writing on that particular input. You will be using all these ways in order to write the thing. Now the same thing here, if you see, these star indicates that they are consecutive. Then that means here if you see, the same here is consecutive 3 clock cycles consecutively, either 2 times or 3 times or 4 times it should be high. Similarly here, if equal to means it should be high for 4 clock cycles, but it is not mandatory, they are continuous. Similar thing this for this also, within the range. That means it can be high for either 2 clock cycles or for 3 clock cycles or 4 clock cycles, but they need not be all consecutive in nature. Clear? So this is how you will be writing the sequence. Now as I told you, if you are having only one sequence, you can directly mention the clock within the sequence itself. Like at the rate of passage of clock, you can directly mention the clock within the sequence, and you can directly assert the sequence itself. But if you are having more number of sequences, as I told you, you will be compiling all those things in a property, and then you will be asserting the property. So how we are going to do it? So if you see here, this is my sequence. Similarly, if you are having some 2 or 3 for one sequence also, you can do it, there is no problem. So I didn't mention any passage of clock because I have just written the logic. So what is the logic? A hash hash star to B. That means after A is high, then the B should be high for next clock. So after 2 clock cycles, the B should be high. Okay, so this is the logic. So based on this logic, I am asserting the property by using implicating this within the property. So here property P at the rate of passage of clock sequence. So what is the sequence? The sequence is A hash hash star to B. So instead of writing all this thing, you can just mention the sequence name. Okay, and similarly, if you are having two sequences, and if you want to check that condition also here at the rate of passage of clock, you can just mention it like that, and then you can assert the property. Okay, you can either write this in this way, or if you are having only one sequence, then you can just initiate the clock within the sequence itself. So this is one way and this is another way. You can do any ways based on the number of sequences you are having, right? So and then the next thing is implication operator. So before going into implication operator, let me show you, since we have already discussed about the sequences and properties. Okay, since we have seen all these repetition operators and all within the sequences, let us do one example on these assertions before going into the implication operators, right? So yeah, let us see the example here before going into the implication operator. So if you see the assertion program here, okay, module assertion, here I am taking clock as inputs and two inputs which are request 1 and request 2, req1, req2. So always I have generated the clock, always at the rate hash 2 is the clock cycle. Total time period of clock is 4 time units. Okay, clock will be negate of clock for every 2 clock cycles, for every 2 units of time, right? And then I am writing sequence, so I am having only one sequence here. As I told you, you can have one sequence or more number of sequences also. So what is the sequence here? Request 1 star 2 hash hash 2 request 2. That means after request 1 is high, then after 2 clock cycles request 2 should be high. So this is my condition. Now I want to assert this condition. What I want to do here, I am just initiating the property. So within property I am writing that at the rate of passage of clock, for every passage of clock, this condition needs to be checked. What is the condition that needs to be checked? Request 1 star 2 request 2 needs to be checked. So I'm writing it in the property, and then I have ended the property, and then I am asserting the property. So this is the way how you will assert. Okay, so assert property of prop. So what is the prop? Prop is nothing but the name of the property. So I am asserting this property. Okay, and then in order to see the waveforms, you will be writing this dump file. Okay, in order to see the waveform on the EDA playground, you will be using this dump file thing. Presently I am not able to open the waveform due to some net issues. So I'll be explaining that in the some other video by showing the waveform. But as for today, I'll be just showing you how the assertion fails on the log file itself. Okay, don't worry, it will be clear for you. Okay, so now I'm just giving the input values. I'm just doing the input values, like if you see here, first initially at 0 time delay, I'm just giving the values as 0 and 0, and then based on the time delay, see, for 4 time units I have made request 1, and then since I didn't give any time delay here, again this also be request 2 also be 1 will for hash 4 only. Next hash 6 request 1 is 0, request 2 is 0, hash 10 request 1 is 0, hash 20 request 2 is. In this way I'm just throwing some values, and then I'm finishing it, and then I'm ending the module. Now if you see here, this is my condition. So now I want to check where the assertion is being failed. Okay, so now if you run this particular property, you will be seen where the assertions are being failed. So from this you can check where the assertions are failed, and then you can check the that particular time point where the assertion is being failed, and you can do it. So let me run it and show you. Let us see where the assertions are being failed. So see, here if you see at 2 nanoseconds the assertion is failed. Okay, and then at 18, at 22 nanoseconds, at 26 nanoseconds. So these are the time slots where the assertions are being failed, and in the remaining thing, in the remaining places the assertions are passed. So let us do one thing here. Let us see this one. See what I have done here is, here after request 1, after 2 clock cycles, the request 2 should be followed. Okay, so this is the assertion that I have done. So for that case, what I have given here, after 4 I have given 6. So it is having 2 nanoseconds of time where both are high. Okay, so because since I have given this, I have the request is the assertion is failed after 18 nanoseconds. Now for example, if I remove this particular 6 time seconds, and if I run this code, what is going to happen? Okay, so the condition like 4 after 4, Here it is again, the request to is 1 for again 4 nanoseconds only, but it's not 2 nanoseconds. That means there is no 2 time clock cycles of time delay. So which is why if you see here at 14 nanoseconds also the session is failed. Okay, for example, if you are not if you are keeping this as hash 6 and if you run this code, what will happen at 14 nanoseconds? You don't see that the assertion has been failed. Okay, so if you see here at 14 nanoseconds it is not failed. Okay, at 18 nanoseconds it is being, the assertion is being failed. Okay, so in this way, depending upon the time units that you observe, you can just check at that particular time in the in the waveform, so that you will get the place where the assertion or the logic has actually failed. Okay, so this is how you will be using the assertions in your um, uh, it's okay. So this is how you will be using assertions in your system Verilog test bench development. So this is all for today, and in the next class we are going to see implication operators within assertions. Right? So that is all today. If you like this video, please do like it and also share it to all the VLS aspirants who also want to learn this Verilog system Verilog and UVM courses. That is all for today. Thank you all.